All right, this is question number 3 from our exit ticket. A large company has 2 shifts, a day shift and a night shift. Parts produced by the 2 shifts must meet the same specifications. The manager of the company believes that there is a difference in the proportion of parts produced within the specifications of the 2 shifts. So that's a key word. I'm going to circle difference. We'll come back to it, see if we need it. To investigate this belief, a random sample of parts that were produced on each of the shifts were selected. For the day shift, 188 of its 200 selected parts met the specification. For the night shift, 180 of the 200 parts met specifications. Use a 96% confidence interval to estimate the difference in proportion of the parts. So we're looking for a difference in proportion. And obviously, they said do a confidence interval, so I didn't need to write a null and alternative. But I did just because it sometimes helps me out. So P1 equals P2. That would be that there is no difference. My alternative would be not equal. Well, you're like, how did I know it was not equal? Well, they used the word difference, but that's not the reason why I did it. The reason I did this is they said 96% confidence interval. All confidence intervals are two-tailed. All confidence intervals are two-tailed. As a matter of fact, 0.96 is here, and then I'm going to have 0.02 here and 0.02 here. So my alpha level is 0.04 because alpha is the area in the tail. So if I were doing that information, that's correct. You didn't have to show this, but I was like, oh yeah, this means I'm basically running a two-tailed test. P1, the true population proportion of parts that met specification from the day shift. P2 is the true population proportion of parts that meet specifications from the night shift. You're like, well, why did I use met specification? Well, because they gave me met specifications here. Could I have done it on the parts that did not meet specification? Yes, but I usually like to stick with specifically what they've given me in the problem and not try to be too creative and confuse myself. So P1, the true population proportion of parts that meet specifications from the day shift. P1, the true population proportion of parts that meet specification from the night shift. Make sure you take it all the way out to from the day shift and night shift. Random samples of 200 from both shifts is given. And they actually told us up here, and I'm not seeing parts, but up here they told us random samples of parts were from each shift were taken. They tell us that right here. Independence. Well, there's supposed to be independent random samples. Reason was to assume that one shift's proportion of defects does not impact the other. In other words, we have 2 independent random samples. N needs to be less than 10% for both. 200, we had 200. And I'm going to assume that each shift makes more than 2,000 parts. Otherwise, they probably would not have taken such a large sample. All right, we had 188 that did not have defects, and that was from the day shift. That means we had 12 that had defects. Well, they both need to be greater than 10. Please remember, this is our normality condition. All right, this is our normality condition. Over here, 108. This is not supposed to be 108. This should be 180. Excuse me. 180 is greater than 10. 200 minus 180 is 20, which is also greater than 10. Both samples are large enough to use the normal approximation. Remember, we're working with proportions, so technically this is a binomial, but as long as our sample sizes are large enough, we get to use the normal in this case. And to be large enough, they have to be greater than 10. Both of these are for all conditions, therefore it's good enough. Now, please remember, this is going to be really important. First off, working proportions, we're always using a Z. That's really important. But the thing that I want to point out is because this is a confidence interval, we are not going to pool. Remember, when we're doing a hypothesis test, we're going to do x1 plus x2 over n1 plus n2. We do not do that for confidence intervals. That is only for hypothesis tests that we pool. So we're not going to do that. So we're going to have p hat 1, q hat 1, p hat 2, q hat 2 over n1 and n2. So p hat 1, day shift, 188 over 200, 0.94. P hat 2, x2 over n2, 180 over 200 is 0.90. We need to show all that work. And then we're going to start plugging in. And we're going to go, okay, p hat 1, 0.94, p hat 2, 0.90. I'll come back to z star in just a moment. So 0.94 times q, and we had a sample size of 200, 0.90 times q, or 1 minus 0.9 is 200. And we need to get our z star. Now this is z star, and it's been a while since we've done this. So second vars, inverse norm, my area, parenthesis, 1 minus 0.96, close parenthesis divided by 2. Please remember, if we're working with a z, our mean is always 0 and our standard deviation is 1. And I end up getting 2.0537. We always make it positive, just makes our life easier. So let's go ahead and run this two proportion interval. So stat test, and I'm going to have to scroll way down. It's not a two proportion z test. It's a two proportion z interval, which is letter B. All right. So x1, well, we have 188 over 200. And for x2, we had 180 over 200. And we needed a confidence level of 0.96. So we end up with this interval. So here's our interval, our lower bound and our upper bound. So here's our lower, here's our upper. And notice we went from negative to positive. Anytime you go from negative to positive, we know that 0 will be included in the interval. So we're 96% confident the true population proportion for the difference in parts that met specification. And we need to give the order. We always have to give the order, which in this case was day shift minus night shift, because that's what we did, day minus night, lies within the interval between, and you know what, lies within the interval, and I obviously have some stuff here that I don't need. Don't know where that came from. Lies within the interval negative 0.0156 and 0.09557. All right. So the difference in parts that meet specification lie within that interval. I don't know where the nurse's part came from. That was obviously from some other problem I copied from. Then we have part B. Part B says, based on this confidence interval, do you think that the difference in proportion of parts produced within the interval by the two shifts is significantly different from 0? Justify your answer. Okay, so we obviously have some difference. We know we have a difference because we have a 94 and a 90. All right, this one has more parts. The day shift has a greater percentage of parts that meet specifications. This has the night shift has a lower part. However, when we run our confidence interval, 0 is included. So 0 represents no difference between the shift. Matter of fact, P1 equals P2. And if I rewrote this by algebra, my null could have been written or expressed P1 minus P2 equals 0. All right. So our claim is that there is no difference. So 0 represents no difference between the shifts. Because 0 lies within the 96% confidence interval, we cannot claim that the proportion of parts that meet specification differs between the two shifts. So basically, Because 0 lies in that interval, we can say that there's no difference, or we cannot say with 96% confidence that there is a difference. All right, thank you. I hope that helped.